going? Yeah, no, thank you. I love seeing some of our partners on here, learning about the product. Obviously, seeing schools that want to learn about it as well. Once again, use that chat box as much as possible. If I'm talking too fast or if you want me to reiterate a point, let me know. If you haven't attended any STEM Wednesdays, these are meant to be about 20-minute sessions. So just quick, high impact. Sometimes they bleed over a little bit. Go into some Q&A and things like that, but really just talking about different ways that STEM can be implemented into schools and districts. So this one specifically, usually they're around topics around the STEM or how to use artificial intelligence in STEM, things like that. Today I'm specifically talking about one of our product lines, which is called the Labdisc All-in-One Science Lab. So I'm going to go ahead and dive into things because I know we're 1 minute past the hour here. And then, we'll continue to monitor the box if there's anything that comes up. So let me go to my slideshow. Hopefully you guys can see my slideshow right now. If you cannot see my slideshow, please let me know as soon as possible. I want to make sure that it's in there, that you guys can see it. I have the chat box up here as well. So if there's any chats that come in, we'll see that too, okay? So can Mark or someone, can you confirm that my slideshow is up? And you guys are good. Okay, cool. All right, so we are going to talk about the magic of the Labdisc All-in-One Science Lab, okay? It's also on the street known as a data logger, okay? So that's sort of the unsexy version term of it, but for the sake of what we call it an all-in-one science lab. So let's dive into a little bit more about this product. You might be asking, what the heck is a Labdisc, right? Well, a Labdisc is a device. We'll talk a little bit more about how it actually works, but it's a device that we've seen schools take and do some incredible science experiments with, okay? So the one we love to talk about and the one we love to showcase is that students have taken this Labdisc All-in-One Science Lab device. They have purchased a weather balloon on Amazon, and they were able to build a carrying case for it. You can see it in the left there, made in styrofoam, and send the Labdisc into near space, okay? This is an image that they actually captured from this carrying case using a GoPro that they had attached to it. And what they were able to do with the Labdisc was activate about 6 different sensors on the Labdisc. So when it got up into near space or throughout the journey, it was constantly recording data about the atmosphere, about the journey. And when it came back down after the balloon popped and it came back down and they were able to retrieve the Labdisc, they were able to take that data and bring it into our software and show all the stuff that they collected. So they collected things like sound data, external temperature data, atmospheric pressure data, altitude data, right? And they were able to bring this in, show it on their actual software, and be able to kind of annotate sort of what was happening on the journey and understand the Earth's atmosphere a little bit better. So it's a really cool way that this specific device was used outside of what we traditionally do in a classroom. And it shows some of the features of the actual product, how portable it is, the fact that it can withstand going into very cold temperatures and still record data, things like that. And, the fact that you can activate multiple sensors at one time and do an experiment. So I have a little video on it. I'm not going to show this to you guys, but if you go and search like Labdisc in space or anything like that, you can see Labdisc in space up here. You can actually watch this video and see them actually kind of launching it up into space. So really cool experiment. We love that type of stuff. And, we always try and push the products in a way to schools where, make it easy for them so they can come up with ideas like this. Okay. Usually the challenge with science, right, is making science hands-on and easy, right? So typically in a traditional science classroom or a science space, you have a massive amount of boxes of sensors and equipment and all this stuff floating around in these spaces. So the Labdisc essentially takes all those sensors and devices and packs it into one handheld device that I have in my image right here. So I'm going to be going back and forth a little bit and showing you the Labdisc on my actual, kind of screen with my face on it, and also from the presentation as well. So we're replacing all those boxes of sensors with an all-in-one science lab. So we always like to say, from 60 different sensors or so per class to one of these Labdisc per table. per table, and really saving about an hour to an hour and a half of setup time and prep. This thing comes pre-calibrated, it comes ready to go. You set it on the table, you can get students around it, and you can do hundreds of different science experiments. So it is a product that can be used all the way from primary through secondary, right? We have schools, elementary schools, young kids that are using the Labdisc. They might use it in a different way, maybe not with the software. Maybe they're just writing the numbers down from the screen when they're doing specific experiments, but you can go all the way to really young students and all the way up to high school, okay? There is 4 different models of the Labdisc. I'm going to talk to you about each model and kind of some of the features of it. But the cool thing is they're all auto-calibrated. They're all ready to go. Now you can see in this picture on the right-hand side, you can see some buttons, right? And I will hold it up. You can see the buttons in here. As I click, you'll hear it makes a little noise. What that's doing is it's activating a specific sensor that's associated with that button, okay? So I'm going to do a little experiment and show you guys a light sensor at some point here towards the end of this, but I can click the light button here, and there's a light sensor on the back of the Labdisc. And oh, you can't see me. Well, you should. I think you have to actually click on the image of me if you want to see that. But essentially behind each of these buttons, there is a sensor on the actual device that allows you to do an experiment with that actual sensor, right? So if you're measuring things like light or temperature, things like that, usually there's a sensor behind. Sometimes there's an external probe that you plug in, but there is a lot of functionality just built into the actual device. There's also a distance sensor on the back of the physics one as well, which is pretty cool, okay? So auto-calibrated, ready to go, portable, lots of good things. Let's talk a little bit more about them. Portable, what I mean by portable is both the size of it and the fact that you can take it outside, do experiments on it, and save it on the device, which is really cool. Another feature of it is you can activate and measure multiple sensors together, okay? I showed you the example, or told you the story of the students that sent this into space. They activated 6 different sensors at the same time. So you can record multi-data experiments with this, which is a really cool feature. We have curriculum with it. We'll talk a little bit more about that here shortly. Super long battery life, about 150-hour battery life with it, which is really cool. And then on-device data caching. What that means is just you can save experiments on the device and bring them into the software later. Okay, so I can run an experiment completely outside of any computer or anything like that. I can be on a hike and recording pressure at different elevation, and then I can bring it back into my computer later, upload that data in there, and then look at it and annotate over it. So we'll show the software and how that works. So very powerful software, lots of cool functionality built within it, and it's really simple and easy to use. Like I said, kindergarten all the way through 12th grade, okay? There's 4 different models of Labdisc. I'm going to show each model with little sensors, but we have a general science Labdisc. You can see some of the sensors that are built into that. So things like decibel levels, humidity, we have the pH of different liquids, light, voltage, distance, things like that. So you can see all the sensors that are come stock on that actual general science Labdisc. So you can use these sensors, once again, to do hundreds of different types of science experiments. And a lot of them come with the product, right? We have a ton of pre-built standards-driven science lessons for K to 12, okay? We have the biology and chemistry unit, also known as the biochem. 14 built-in sensors. You can see some of the sensors that are in there. So each one of these models functions the same, just has a little bit of different stock sensors. Then we have the physics unit with 10 built-in sensors. So you can see what some of those sensors are, really geared towards physics. And then we have an environmental one as well. The one thing I do want to stress is that you are not stuck with the sensors that come on this specific device, okay? There is an external kind of area where you can add sensors to it over time, right? So if you have the environmental one and you really want a heart rate monitor, right? We have heart rate monitor as an external sensor. You can purchase that and then add it to the environmental one to do heart rate monitoring, okay? So there's lots of external sensors as well, so you can kind of grow its functionality over time. So really just, looking at the one that kind of suits most of the needs that you're looking for, and then adding additional sensors if needed. We have all sorts of Labdisc projects. Like I said, when you get any of our STEM products at Boxlight, you also get access to our curriculum platform, which is called mystemkits.com. And we have tons of Labdisc projects within mystemkits.com. We have stuff where if you have a 3D printer, we have 3D printable projects that you can do, but we also have lots of lesson plans and activities in there as well. You can see things around Newton's laws of motion, weather tracking, microclimates, Boyle's law, all sorts of really cool Labdisc projects. Here's some of them kind of in action with what the actual lesson plan is called and what grade levels are kind of geared towards. So things like what's the fuss, what's weather like, shade structures, things like that. So lots of really, really great experiments. I'm going to stop here for a second. I want to make sure no one has any questions. Uh, I know I'm moving pretty fast through this. We like to keep these pretty, quick, 20 to 25 minutes. Is there any questions that have come up in this? Go ahead and type them in the chat box. If there's nothing typed into the chat box, then I'm just going to keep going on this. So I'm going to give it another second or so. I am moving lesson plans, just moving into some of the lesson plans, and then we're going to I'm going to show you how this product works, and we're going to do a couple of quick experiments here as well. Okay, so the cool thing about the lesson plans and how they're built out for the Labdisc, now this product can function as something to supplement what a science teacher would already be doing, right? Science teachers are already doing things around pH. They're already doing things around like light. They're already doing things about microclimates, whatever it may be, right? And so this device can come in and act as a way to measure that data and log that data. But we also have tons of our own lessons that come through. Someone asked how many discs are recommended per class, and great question. We have two options. I'm just going to jump to that to show you that briefly. So we have three options. One is singles. This 8-pack is probably the most common option. Okay, so when we put one of these discs on a table, we usually recommend about 2 to 3 students per disc. Okay. And, we always want in STEM, right? And STEAM, we always want to focus on collaboration and have students working together. So if you have a class of about 25 or so in that range, 20 to 30, usually an 8-pack of Labdisc works really well in that space. Okay. So great question. And I'll put my information at the end of this. So actually I'll type it in right now. If you want any additional information, or if you want me to send you something, I would be happy to do that. Maybe I can't do that. Well, 1 second. It's just, hold on 1 second, guys. I'm going to reshare my screen. I don't know what happened. I started drawing on me. I think I was clicking on the annotate or something like that. So I'm going to go ahead really quick and put my information in here. So if you have any questions or want some pricing on it, please just reach out to me and I will get you anything you need on that. So hopefully that answers that question for you. I want to have a little bit of fun with the Labdisc with you guys, just so you can see it kind of in action and see how it works. I think that's the most important part with this product. So there's a couple of things. One, I'm going to show you sort of how we set up the experiments. We're going to talk about 2 of them and we're going to do 2 of them. Okay. So I'm going to show you a couple of different experiments and how it works. So the first one is what's the fuss? We're not going to do that, but what's the fuss is an experiment about measuring the pH of different liquids. Okay. So there's kind of 3 parts to an actual experiment that we have in our curriculum platform using the Labdisc. One is like learning about the topic, right? So learning about pH. What does it mean? What does it mean for our body? What does it mean for the environment? The second thing is actually coming up with a hypothesis, right? So which of the following drinks do you think will have the highest pH, right? Then you actually do the experiment and come up with the data, right? So proving or disproving your hypothesis, right? Typical science class kind of sort of process there, but that's how it would work with these actual lesson plans that we have. So learning about the topic, hypothesizing, experimenting, and showcasing data. Okay. So we do a little thing about which of the following drinks do you think will have the highest pH and what does that mean about the pH levels and what we consume and all that. And so we use our pH probe and dip them into different liquids, and then we record that data and showcase it. One of the ones that we're going to do here, because I have fire, which we all like, is measuring the heat of a flame. Okay. And we're going to do that with, there's a sensor on one of our Labdiscs called the BioChem Labdisc. There's a thermocouple sensor, which you can measure very, very high heat. Okay. You may or may not be able to see it in my screen. So the one that has my image in it or my face in it, but I'm holding it up and I'm holding the thermocouple sensor. I'm going to go into the software and I'm going to show you how it works. So I'm going to share my screen with that. But what we talk about is obviously what is happening in a flame what's happening with the heat, what's happening with convection, what's happening with carbon dioxide, things like that, right? So learn about that topic. And then we hypothesize which of the following parts of the candle flame do you think are the hottest? Okay. So is it the blue area? Is it the orange brown area? So you can kind of see in this area right here. It's the blue area at the bottom. Is it the orange brown area, or is it the yellow area at the top? Do you have any hypotheses that you'd like to share in the chat? I'm going to bring up the software. I'm actually going to do a little live experiment for you guys so you can see it in action. But if you have any hypotheses about that, please put that in the chat. I want to see what you guys think. I'm going to share the software so you can see kind of how that looks. I haven't seen anyone have a hypothesis yet, but which part of the candle flame is the hottest? Anyone? So red, yellow, cool. So a couple of predictions here. So the cool thing about the Labdisc, very, very simple. You plug it in via USB or you Bluetooth it to your computer. Once you do that, you kind of just, actually, I'm going to share my whole screen so you can see everything. Okay, my whole desktop is now shared with you. So you click this little button, it activates this, which allows you to choose which sensor you want to use. Now I'm using my thermocouple, which measures high heat. Okay, so I click the thermocouple. I can choose how fast do I want to receive my samples, and then how many samples in total. Okay, I just do 10,000 max because I can stop it whenever I want. Okay, so now I'm going to measure the flame. In order to run the experiment and see live data, I click run. Pretty simple, right? Now I have my flame here. We're going to go with the blue zone first. So if anyone guessed the blue zone, we're going to bring that up and see what the heat is of the blue zone. Okay, that's pretty much where we're at here. So I'm going to take it out. Now we're going to go with the kind of brown orange zone. Let's see where we're at there. You can see quite a bit hotter. So if anyone guessed that, and now we're going to go to the yellow zone, or the top of the flame. All right. So if anyone guessed the yellow zone, you would have been correct. Anyone guess that? I actually didn't even see. I was focused on doing the experiment. So it looks like oh yeah, Kate answered yellow zone. So love that. So now I'm going to stop the experiment. Now for a student, right, this is now the data I've collected. This is what I'm proving or disproving my hypothesis with. What's cool is I can go in here and now start creating some data points, okay? So I can click on my little data spot. I can create a couple of data points. I can go in here and click my little annotation tool and put blue zone, right? I can add an image if I want to add an image, okay? So I can add an image and put, let's say I have my yellow zone, I don't know if I have a blue zone in here, but let's just use this for now. Actually, oh, blue zone, there it is. Okay, so I can put my blue zone in here. So I'm designated that that's where that happened. If I want to do another one, I can say my brown or whatever zone is the middle one. I can put my orange brown zone, right? So it's pretty cool. I can showcase, and then I can do another one over here for the yellow zone, which was the winner, if anyone guessed that. Add an image for the yellow zone, okay? So pretty cool. So now I have my 3 data points. And now as a student, I have kind of completed a science experiment. I can showcase this to the class. I can submit this with my actual lesson that I went through. And this is like really in a simple way, proving or disproving a hypothesis I had for that, okay? So this is one of the experiments. We're going to do one more experiment here in a second. But I'm going to jump back into the presentation here. Once again, if you have any questions, please type them. I want to know what you want to ask. Okay. Moving over here, I'm going to leave it on this mode right now. I'm not putting it in full screen mode. So next thing is some of the results, right? So showing which area was the hottest and why. So talking through that with students is obviously part of it as well. Another experiment we do with this Labdisc is the Newton's laws of gravity. And the way we do that is we have a distance sensor with this on the back of it. And it's like a sonar distance sensor. We can drop a ping pong ball. And then as it kind of bounces, it creates parabolas or in the actual data. And you can measure the actual distance between those. And that's how you can get gravity. So really cool experiment that we do with that. I'm not going too in depth on the actual software itself in this short call, but happy to go through it with people if you're interested. And then the last one I want to show you is a light absorbance one using sunglasses, okay? So we have a light sensor on the Labdisc. And what we're going to do, if I can pull it up here, we're going to use the actual light sensor and we're going to use our phone to show light. And then we're going to measure it with 3 different pairs of sunglasses, okay? So once again, I'm going to share my screen here. I'm going to show you how this works, okay? So sharing my desktop, you can see in the software, very simple. It's connected with this little, I'm plugged into my computer, so it's connected down there. I click the little Labdisc icon. I want to measure light, and I'm going to do it at 10 per second and that many samples. And then all I do is click run experiment, okay? I'm going to turn my phone flashlight on and I'm going to point it at my Labdisc so I can get light, okay? Now, whoops. Now I have kind of my baseline of light here, which is going to shine on my Labdisc, okay? So here's my baseline. I'm going to let it get kind of settled. All right, there we go. Now I'm gonna go with 3 different pairs of sunglasses. We're going to go with a very cheap pair and see how much light that it blocks from its lens, okay? So this is a cheap pair right here. Kind of a baseline of it. We're going to go with a mid pair. Okay, and I will show you how we can look at what the lumen is through this. And then we're gonna go with a very expensive pair. Okay, how effective are the frames of these sunglasses? All right, so we went with a light, kind of a very inexpensive pair first. So I'm going to show that. This is a more mid pair, and then this is a more expensive pair. So you can see my actual light was about 71 lumens. On the inexpensive one, I had about 72. And then if I bring this over here, I had about 97 that passed through. So actually, surprisingly, the most inexpensive pair of sunglasses blocked the most amount of light from my eyes, which is quite interesting. Now, that doesn't necessarily mean that they're the best pair of sunglasses because, you know, there's other factors to consider, but it allowed the least amount of light actually through. Do we have any questions come through? Are the lessons, can you use multiple sensors at the same time? Yes. With this product, you can activate multiple sensors at once. I had just done one at a time, so I was just doing light. But if, like I had mentioned in the first example, with the actual school that sent it into space, they had about 6 different sensors activated at the same time. So you can do multi-sensor experiments, a huge feature of this actual product. And it's, like I said, it's very portable. You can save the actual experiments to the device and bring them into the software later. Now, if I had an experiment that I wanted to bring into the software later, there's a little download button here. So I would click that and I would choose which experiment I wanted to bring in and download it. And it would bring it into the software and show me the data like this. Okay. So once again, really cool. If I wanted to show my cheap sunglasses, you know, I can do that. I can create a bubble shape. I can add image. So I think I have a couple of pairs of cheap sunglasses in here. So yeah, just really cool ways to kind of showcase the actual data that you just collected. So that's one of the big features of it. Kate said, are there lessons that have the Labdisc run overnight? Yes. So great question. If you guys are still on here, there is kind of 24+ hour experiments for the Labdisc where you can measure like climates and things like that overnight, or what happens with the temperature and things like that from sunrise to sunset, things like that. So the beauty about this product, everyone, is that it has a 150-hour battery life, okay, runtime. You do not need to charge this thing. I know with a lot of steam products that are out there, you need to charge it kind of consistently. So Labdisc lasts an extremely long time on battery. Once you're, you know, kind of done using it, you can put it onto one of the charging trays and things like that, and it will charge back up in a very short period of time. So thank you for asking that. It is really good. Once again, this is kind of like a charging tray that comes with it. So you can kind of flip this around. There's little prongs at the bottom. You can drop it in the tray and it'll start charging it, but it does have a 150-hour battery life, which is really great. Okay, so this was the experiment we just did, kind of learning about sunglasses, what the lenses do, how they protect you, and then kind of testing a couple of different ones to see how much actual light went through it. Is there any, I know we're kind of coming at the end of this. Is there any additional questions that people have come up with in regards to the Labdisc? I know there's some, Mark asked something about calibration. We kind of covered that in the features in the beginning. So talked a lot about the features of the product. So, portable, remote data logging, multiple sensors you can activate together, curriculum included. It can save experiments on this device, and it's all pre-calibrated and ready to go, guys. So once again, the big feature here is you're saving a lot of time with setup, which is huge, and you're kind of reducing all the equipment you have in a science space and packing it in one simple, powerful device. Okay, so this one device, up to 15 different sensors, hundreds of different science experiments, and there's a couple of different models: general science, biochem, physics, and environment. Okay. How many lessons are available per disc? Great question, and thank you so much for asking that. So when, like I had mentioned, when you get the Labdisc, you get access to our curriculum platform at mystemkits.com, an incredible curriculum platform. If I go into it, I'm showing it to you guys now, and I click Labdisc sensors, you'll see we have tons of kits, lesson plans, things like that for the Labdisc, and it's constantly growing, okay? So lots of exciting things happening with the Labdisc, and lots of activities and lesson plans to go with them, okay? So, and we're always building new stuff. So it's gonna be something that's constantly growing, and something we're constantly adding to when it comes to this product. Now, if you are on here, you're listening or you're watching a recording, we do have a Labdisc coming in August, specifically for elementary, okay? I know we're kind of at the end of this. We've gone over about 7 minutes, what we normally do, but I did want to bring this up to you if you're still hanging around. So there is a new Labdisc. It is called the Labdisc Exploris. Once again, it is geared specifically towards elementary, but one of the great things about this device is it has built-in sensors with it, but it also gives you the capability of being able to do art on the actual screen and animations. So you have some of that part of STEAM tied to it. You can do different coding things with it. So kind of block-based coding or Python coding with it. So for example, you see a little flower on the screen. I can have the flower open up if the light sensor on the Labdisc is exposed to light. So you can do some cool stuff like that with it. And then it also, you can use it just like a data logger, like I showed you with the current Labdisc. So you can measure actual data collected from the sensors that come on the device. Super duper cool. It's kind of an all-in-one STEAM device and science device for elementary. So stay tuned. We're gonna be sharing more with that as we go along, but that is in the works. Once again, I gave you guys my email on there. If you have any questions, please do not hesitate to email me. I'm also going to put it on the screen here. I would love to help you out, get you some information. If you're interested in getting some pricing, things like that, please send me a message so I can get that information over to you. I'm going to hang around if there's anything else. Mark, thank you so much. Any other questions that come up, I'll hang around for a minute or so. But if not, reach out to me. I'm going to put my email in here. If you are attending these STEM Wednesdays pretty regularly, next week's is on advanced 3D design with Fusion 360. So kind of moving it back towards 3D printers. So if you have students that want to attend, please join that. So we're going to do some 3D design using Fusion 360. Okay. We post about them on our LinkedIn channel. We post about it on our social media. So let me know. And thank you so much for attending. Thanks for your questions. Once again, reach out to me if you have any questions. Happy to help get you some additional information. And thank you guys so much. Look forward to working with some of you in the future. Take care.